All right, so we're going to take a look at the 2014 individual round or event for the Math Olympiad school-to-school head-to-head competition. Each one of these points question is worth 1 point, and your individual scores go towards your individual words, and the average of all 5 team members go towards your team score. So that's how that works. So last year, the top 3, 1, 2, 3, all tied with 7 out of 10. So are you expected to get all 10? No. If you're getting 5, you're doing really well. 7, you have a chance to win. So let's take a look at this. What's working? What number belongs in the box to make the statement true? Well, let's look at this side, and I notice we have 4,321 times 22, and over on this side I have an 11 times something, which is going to be equal to this. So obviously I could multiply this together and then divide by 11, but that would kind of be silly because it's much quicker to look for connections between the two sides. Well, what do I see that is similar between 11 and 22? Well, I know that 22 is 2 times as big as 11. Well, if it's 2 times larger than 11, that means this number here is going to have to be 2 times this value in order for the two sides to be equal. Because if I divide this by 2, or if I divide this by 2 to get this, then I have to do, this number has to be twice that number to get an equal statement. So really, it'd be much easier to do 4,321 times 2, and I will get 8,642. And that's the answer that would go in the blank. All right, the next question. The next question says, if Mary had 20 lambs, all but 6 ran away, how many lambs does Mary have? And most of you should be looking at this and thinking to yourself, you gotta be kidding me. Because if Mary had 20 and 6 ran away, then, and all but 6 ran away, then obviously she has a total of 6 lambs left. That is just a straight logic question, which I would hope you would have no problem doing. All right. So again, that was 6. All right. So the first 2 ones, pretty easy. Third one gets a little bit trickier. And we've gone through these types of problems in class, so hopefully we'll have access to this one. So we know that 360a times AB is going to be equal to 3,600 AB. And so I'm looking at this, and the first thing that we notice, the very first thing that we notice, is that B times A is going to be B. Well, there are only a couple things that B could be and A could be. Obviously, if A is 1, so A has a possibility of being 1, that would hold true because 1 times any number is always that other number. What else could it be? Well, A could be an odd number, and that would make B 5. And I'm just writing possibilities now. But if that's the case, if A is going to be an odd number, any odd number other than 1 times 3, well, 3 times 3 is 9. But if we're having to borrow it all, we're going to go into another place value. So we know that A cannot be 3 or any other number. So really, we're left with A having to be 1. A has to be 1. So let's write out the problem as we know it. We have 361 times 1 times b, and we know that's going to be 3,600 b-teen, or whatever you want to call it. Now, this is where things get really sort of easier and interesting. The only way, the absolutely only way we're not going to end up with another place value is if we're multiplying if b is 0. Now, if b is 5, let's go on. So we know right now b is either 5 or 0. Let's go down the rabbit hole with 5. It's not the right answer. But if we have times 15, let's see what happens. So we get 5, 0, 3, carry the 3. 5 times 3 is 15, plus 3 is 18. And then we have the 361, and already we see, because we have a value here, we're going to make this 4, right? So it can't work, right? So we know 5 is out. So the only real possibility here is going to be 0, because that's the only way. It's the only way that we're going to end up getting a 3 here, a 6 here, and a 1 here, because then you don't have another. The units multiplication doesn't net you anything other than 0. And my board's misbehaving, so sorry. So we know that b has to equal 0, a has to equal 1, therefore ab represents the number 10. A restaurant has 5 tables that seat 2 people each, 10 tables that seat 4, 3 tables that seat 6. Each waitress can handle up to 15 people. What is the fewest number of waitresses if every seat is taken? So this is just a simple multiplication, addition, division problem. We need to figure out how many people this restaurant can hold. And so if we have 5 tables that seat 2, that's a total of 10 people. If we have 10 tables that seat 4, that's 40 people. And if we have 3 tables that seat 6, that's another 18. And so we can have a total of, anytime that, there we go. So we can have a total of 68 people. Well, if each waitress or waiter can handle up to 15 people, we just have to figure out how many times 15 goes into 68. So 15 goes into 68. Well, we know 15 goes into 64 times. And 4 times 15 is going to be 60. So we have a remainder of 8. Well, if each server can only take 15 people, then we need more than 4, right? We need 5 servers, don't we? And so we know the answer is 5, because if we don't have one more extra, then some of the servers are going to have more than 15 people, which would not be okay in this restaurant. Number 5, how many odd numbers between 10 and 100 are divisible by 3? Well, there are a couple ways to do this. First, let's figure out how many total numbers are divisible by 3 in between these. Well, I know that between 100 and 10, there are a total of 90 numbers. And we can go through and write them out. I mean, we don't want to do that, right? And of these 90 numbers, how many would be divisible by 3? Well, every third number is going to be divisible by 3. So 90 divided by 3 is going to equal 30. But wait, we are not looking for all the numbers that are divisible by 3. We are only looking for the odd numbers that are divisible by 3. Now, if I look at a small sample of these numbers that are divisible by 3, 12, 15, 18, 21. We notice that every other number is even and every other number is odd. Therefore, of the 30 numbers that are in my range, only half of them are going to be odd. Well, what's half of 30? 15. So there are 15 total odd numbers divisible by 3 between 10 and 100. All right. So this is a really cute drawing. I'm going to have to make my pen a little bit smaller. So I'm going to label these angles 1, 2, 3, 4. We know that those are all acute angles, and we'll remember that acute angle, other than looking nice, is going to be less than 90 degrees. It cannot equal 90 degrees because that is a right angle as opposed to a wrong angle. And angles larger than 90 degrees are obtuse. So anything that is less than 90 is called acute. And so far we have 1, 2, 3, 4 angles that are clearly acute. Well, because this is a right angle, we know that this right here is going to be acute. So here's 5, 6, 7, 8. So right now we have 8 total angles. And I'm going to write this 8 over here because I'm getting old and I'm liable to forget that I have 8 angles here. So we'll just write it down to help ourselves out. But I can also combine some of these angles. For instance, if I combine these two, well, that's acute. If I combine these two, that's acute. If I combine these two, well, that is also acute. So then I have 3 more. So right now I have a grand total of, that's right, 12. So then, oh, sorry, 11, because 8 plus 3 is 11. Yeah, you're probably thinking, all right, never mind. All right, so then, what about combining 3 of the angles? So I can go 1, 2, 3, 1, 2, 3. Well, that gives me 2 more. And if I try to combine all 4, that makes me a right angle, which, again, in this case, is just wrong. Math humor really is not that funny. Sorry. So I can't make any other angles up, and so that's a total of 13. All right. Number 7. The meaning of 2 factorial is 2 times 1. The meaning of 3 factorial is 3 times 2 times 1. And 4 is 4 factorial is 4 times 3 times 2 times 1. And so their values are 2, 6, 24, respectively. So what is the value, or sorry, what number, whole number, must you subtract from 5 factorial in order to get the largest perfect square number that is less than 5 factorial? Well, we notice that 3 factorial times 4 is this, right? So 6 times 4 is 24. That means 5 factorial is going to be 24 times 5, which is a grand total of 120. So we're looking for square numbers less than 120. Well, what is the largest square number less than 120? Well, 121 is larger, so that doesn't work. So the next largest would be 100. So 100 is a square number, and you know that 10 squared is equal to 100. For those people who know square roots, 100, square root of 100 is equal to 10. So what did we subtract 120 by to get 100? That's right, we subtracted 20 and to get our 100, so the answer is 20. I always hate it when students do that, so there you go. All right, 8. A poster contains 2 rectangular photos, A, B, C, D, and J, K, L, M. Let's draw this out. When you have a geometry problem, you should always draw it out. So here we have A, B, C, D, and then let's have a little color difference. Don't get me wrong, I love orange, but now we have J, K, L, M. And on the poster, AB is 40. Mixing colors. BC is 30. Well, what does that mean? Well, that means this is also 40, and this is also 30. And it goes on to say that JK, not only is JK just kidding, it's 28, and KL is 24. And if the poster and everything on it is enlarged uniformly, that means I don't know if you've done scale factor stuff yet, I don't know. But that means everything's growing at the same rate. So whatever you grow this figure by, this figure will also grow that much. So, and it's grown so that the new A, and I'll do a red here. So the new one, can also A prime, B prime, C prime, D prime. Incidentally, the prime is just saying that A and A prime are related but different. That's all it means. And now AB prime is going to be 50. What is the area of the enlarged photograph here? And so we have a new photograph, J prime, K prime, L prime, and M prime. Okay, so the question is, what did I multiply 40 by to get 50? Well, in other words, I'm saying 40 times something is equal to 50. Well, wouldn't that just be the same as saying something is equal to 50 divided by 40? Yeah, it would, wouldn't it? So that something is equal to 5 over 4. Great! That means that if I multiply this figure by 5 over 4 to get this one, I have to multiply this figure by 5 over 4 to get my new one. So let's multiply some fractions, shall we? So we have 28 over 1 times 5 over 4. Notice how I didn't plan ahead, I'm totally losing space. The first thing I'm going to do, and I don't know if Dubs taught you this, but the first thing I'm going to do is I'm going to reduce. So what goes into 28 and 4? Well, 4. How many times does 4 go into 28? It goes into 28 7 times. Oh, look, Christmas. How many times does 4 go into 4? 1. So what is 7 times 5? Well, 7 times 5 is 35. What's 1 times 1? That would be 1. So that means that the length of J prime K prime is equal to 35. But we can't find the area just with one side length. We need to find the other side length too. So that means we have to multiply 24 also by 5 over 4. And we notice that brilliantly 4 goes into 24. 4 goes into 4 6 times. So this ends up being 30. So now we just multiply the 30 times the 35. So 35 times 30. Well, let me think here. So we have a 0 at the end. 3 times 5 is 15. Carry the 1. That's 9. 5. Thank you. And so we end up with 1,050. That's it. You can see the problems are starting to get a little bit harder, aren't they? All right, 2 more. Here we go. All right, number 9. What is the value of 2,500 plus 2,499 minus 2,498 minus 2,497 plus, I see a pattern. So essentially we're adding 2 numbers in descending, and these numbers are continually descending, and then we are subtracting 2, then adding 2, and subtracting 2. And that pattern is going to continue until we get to 1. So the way to think about this is we know that there are 4 numbers in an entire series before the series repeats. And when I say series, I mean 2 positives and 2 negatives. So let's see if we see anything common in each series. Well, what is 2,500 minus 2,492? Well, that's 2, right? I'll write it out. So I'm just subtracting the largest, sorry, I'm taking the largest number and subtracting the smallest number, and I'll do that again. So I'll have 2,499 minus 2,497, and what's the difference between the two? Well, it's 2. So that means for this whole series, we have a combined total of 4. Let's see if that happens over here. What's the difference between these two? Well, that's 2. That's right. What's the difference between these two? Uh-oh. These are both positive. So for every group of 4, I will have a sum of 4. So the question is, how many groups of 4 are there in 2,500? And each group is going to have a sum of 4. So we're going to do 2,500 divided by 4, so we can figure out how many groups there are. And so 4 doesn't go into 2, but 4 goes into 25. It goes into 25 6 times. 6 times 4 is not 40, 24, until it's time for me to go home. And so we subtract, so we get 100. That goes in 25 times. So there are 625 groups of 4 in 2,500. Well, if each group of 4 has a sum of 4, we multiply it and we get. Now, you may have noticed that that was going to be the answer sooner, because if each group has 4, has a sum of 4, and we want to know how many groups of 4 went into 2,500, then clearly, the sum is going to be 2,500. But if you didn't see that and you went through this math, great, you got the answer. Last problem. All right, the fraction x can be called an extended complex fraction. What simple fraction in lowest terms is equivalent to x? Last problem, this is a good one. All right, so let's start with the bottom right here. So we have 4 over 1 plus 5 over 6. So, well, to add fractions, you have to have common denominators. So really, this thing is equal to 24 over 6, right? Yeah. So we add it together and we get 29 over 6. So what that means is we have to rewrite the fraction, 1 over 2 plus 3 over 29 over 6. And we learned in class that in this case, this bottom denominator gets kicked up and we multiply these. So we end up with 1 over 2 plus 18 29ths. Well, and now we start the process over again. Now we need to add 2 plus 18 29ths. Well, 2 is equal to 58 29ths. So we have 1 over 58, oh, come on, 58 29ths. Good for you if you can follow along on this one, plus 18 29ths. So you add those together, and you get, sorry for the hiccups, you get 76. So you get 1 over 76 over 29. Bottoms up. 1 times 29 is 29 over 76. Now obviously I skipped ahead, or I didn't talk about why this is true, so I will now. In this case, when you have 3 divided by, I'm going to write it not as a fraction, we're going to write it as a division problem. 29 over 6. How do you multiply fractions? Well, you multiply by the reciprocal. So that's how we get the 18 over 29. It's a little bit easier to just remember to kick the bottom up. All right, so there are the 10 individual problems. I hope that helped.